Hi, Nancy Baker here. Today I'm going to show you some more advanced techniques to use with term mapping in the abstract sifter. I am using version 8. If you're using an earlier version, maybe 7, it will also have this functionality. So I just ran a query, and I'll show you what the exact language of the query was. I'm looking for information on this particular chemical, and I threw in a couple of variations on the names, some synonyms, and I just ran that. 662 rows were brought back. That means 662 PubMed entries or citations for that chemical. All right, so to motivate term mapping, and probably if you've watched the other video I did on term mapping, you probably already know what it is, but let me go ahead and motivate it anyway. Let's say for this particular chemical, I'm interested in dose studies in rodents. Well, of course, using the 3 Sifter terms is a great way to find dose studies in rodents. So I might put here rats, mice, and maybe MIGs. And then I can sort on these 3 things here. And when I look at the results, I can see, first of all, this NTP article right here has lots of information on rats and mice, and it's obviously, if I read the title, I can tell that it is definitely a toxicity study on 1,2-dichlorobenzene, and you can see how many times the terms rats and mice occur along with MIGs. So that helped us, using the Sifter terms helped us find that article very quickly, and you can see that there are probably a lot of articles here that have information on rats and mice. Here's one that's just on rats, and then there are a bunch just on mice. There's another way to do that, and that's to use term mapping. So let me go to term mapping, and I've cleared it all off. And let me go through the motivation behind term mapping. So let's say again you're looking for rodent studies, toxicity studies, and you're looking for rats, and you're looking for mice, and you're looking for, mouse. I'm not going to put rat, or I'm going to put rat in this space, and then dose, mix, and maybe I'll also put parts per million in case it's put into water, air, and then I'll put pups in case it's some kind of developmental study. I'm going to put rodent here. Alright, so if you have any familiarity with term mapping, you'll know that when I click this button map, it's going to take every one of these strings of characters and go out to the main sheet and find every article that it's in, or every citation. I'll use the word article, I mean citation, and then it will count the number of citations from the main sheet these strings of characters are in. So if you're looking for rodent studies, if a citation has one of these terms, you might be interested in it. If it has 2 of these terms, you might really be interested in it. If it has 5 or 6 of these terms, you know you're interested in it. And if you rank things on the main sheet, the articles on the main sheet, by the number of hits, I can say, that it has on this list, you're going to find the most articles that are the most about rodent studies. So I'm taking this small list, and I'm going to click on map, and you can see that does it very quickly. It counts the number of articles. I double click on rodent. That just writes TX:rodent. That means term mapping. It's my prefix for term mapping, rodent. And the one that comes up is comparison of hepatic and renal effects in the rat and mouse. And here's our NTP study here, and some other ones that receive a high score. To show you what's going on behind the scenes, if I double click and come to the abstract sheet and look at the colors here, you can see the purple is the term mapping terms. So here's the false positive. It's rat inside of a word, RAT inside of a word. That's something you do have to watch out for, because it is looking for strings of characters. Now down here at the bottom, you can see what the abstract sifter has done to the abstract, and it's just the abstract in the abstract sifter. It doesn't affect PubMed at all. It's appended some term mapping cross-references so that you can count. It helps with the count on the main sheet. 1, 2, 3, 4, 5, 6, of those, and that's what's being counted here. There's the 6. So in the case I just showed you, I put the terms in for rodent studies. I've gone ahead and stored a bunch of lists of terms that you can start out and use if you want. And here they are. These are ones that I've just put together. They're starting points. Just go ahead. If you don't care about this sort of thing, you can go ahead and delete that. Change them any way you want to. Add to them, subtract from them, so on. And I click on map, and it will go count those terms on the main sheet, those strings of characters. And when I double click here, I pretty much get the same results, but it's a little faster because I didn't have to type anything in. I have a whole bunch of lists here that you can go pick. Here's some easy ones here, right here, phys chem. Let's go ahead and say yes on that. Here's a bunch of phys chem type stuff. And if I say map there, double click here, this article has the most phys chem terms in it. I wanted to show you environmental, I wanted to show you one more thing here, is I also have this drop down. When I started getting too many lists to put on that form, I put them on this drop down, and you can scroll through here and find terms as well. Okay, so I went ahead and clicked on the fate one, and I'm going to map that and show you that too. You can either double click on this column B term or column A term. If you double click on column B, it writes that term to the Sifter cell and sorts. And so that's about biodegradation. And if you click on the first, it'll put TX fate up there. Or you can just type in, what was that called? Okay, I'm back, and I corrected my spelling. So anyway, I'm looking, what I did now is in B3 Sifter cell, I put the name of the chemical 1,2-dichlorobenzene, and I'm going to sort on that. And this, of course, is a very common thing to do when you're looking for literature about particular entities, in this case about a chemical. But the thing about entities in chemistry and biology is they often go by a bunch of different names. So our NTP study here has 13 occurrences of 1,2-dichlorobenzene, but you can see here that O-dichlorobenzene is in parentheses plus the CAS number. We did search for those things, but if we sort on smallest to largest, you can see a lot of these articles, if I'm doing sifting on this name, nothing is coming up. So I'm scrolling down, and I'm seeing that there are other ways to talk about this article, about this chemical. Put that in there. And you can see now I'm picking up O-dichlorobenzene, and then I bet if I look, that we'll find that there are other ways to write the chemical name. I should have had some prepared, but let me just show you that I earlier actually went through and looked up all the different ways that people write 1,2-dichlorobenzene, and a lot of times they're abbreviated with DCB. So let's look for DCB. ODCB or just DCB, lots of different ways to write this particular chemical name. And it's kind of important when you're doing a literature search to not only look for terms, say, having to do with fate or rodent studies, but to count the number of terms for your chemical in the article, because that shows that that article is really about your chemical and not just mentioning your chemical. So in this case, these particular articles here only have O-dichlorobenzene once. Maybe they're not really about dichlorobenzene. Maybe they're about some other chemical, or in this particular chemical is a reagent or something like that, and just used in the experiment. So what I'm trying to get to here, and I'm not doing a very good job of explaining it, that one of the things we want to count is the number of occurrences of the chemical or the chemical of interest, and that chemical of interest can be expressed in many ways. So term mapping is really good for that. So I am going to take this list, and I went overboard with this. You don't need to be this complete. And I'm going to copy those, all these different ways of writing 1,2-dichlorobenzene, and put it on the term mapping sheet. And now I'm going to add my environmental fate to the bottom and say, don't want to clear it. So now I have sort of two different sets of terms. I'm going to say two different term vectors or feature vectors. One is for fate and one is for the particular chemical, because I want articles, I would think that I want articles to read first that are really about my chemical and really about fate of chemicals. So I'm going to map both of those things, and then I'm going to look at the results together for the chemical and for fate. And you can see then, if I'm really looking for this combination, I can take the zeros off there, and I'm just put the word water here. Just these, you can look and see visually which are the ones you're probably going to want to start with. Certainly some of these here, and those here, and then I'm probably the last ones I'll look at if I, having to do a systematic, complete literature review, are the ones here that only have occurrences of fate once, and maybe, let's see what that is. Yeah, so this has got dichlorobenzene, and then this in parentheses, that's kind of twice, and here it is again. So that, might be something I'm interested in, but it only has one fate term, which happens to be sorped, which, is part of absorption, could be fate, looks like in this case, not. So again, I could start to segregate the articles that I'm really interested about the fate of this chemical from the things that just happen to mention fate terms or mention this chemical. And I'll want to start, maybe with those up here that are really sort of densely about fate and this chemical. And to look at that, to visualize that concept, here is the actual data. Here it is right here, the data, and here I've graphed a dot plot the data. This is so this particular dot represents citations articles with 10 mentions of the chemical and 3 of fate, and here's 8 mentions of the chemical, 4 of fate, and you can see that the ones that we're going to want to start with are those up here that are really about fate and really about our chemical, and then, if we need to, move this direction to those that are less about our chemical and less about fate. So again, sort of a two-dimensional search, vector search, if you want to call it that, so that we're using a lot of concepts and ideas here from text mining that we've made it so easy we don't need to do anything automated, we don't need to train any models, we don't need to do anything fancy, we're just using these two sets of terms.